All right. Video 2 of 8.5. We're going to continue the discussion on factoring. The last video ran a little long, so I'm going to cut this one down. Our EQ is just how do I factor trinomials that have negative c values. In the first video, we talked about positive and negative b values. What happens if that first value is positive or negative? What happens if the middle number is positive or negative? But we didn't talk about what happens if c, the third number, the plain number at the end, is negative. So just a quick recap of what we did yesterday. Okay. Again, the idea of factoring is to present or to create two sets of parentheses, two binomials, that if I were to multiply them together, I would get x squared minus 15x plus 36. So what we saw is that in order to get x squared, that first term, I'm going to need to multiply x with x. Okay, and the rest of the problem can kind of be focused in on just the value of these two numbers. This is my b value of negative 15. This is my c value of positive 36. And the mantra or the kind of motto we stood by is I want to find two numbers that multiply to c. In this case, multiplies to 36, but has to add up to the b value, which in this case is negative 15. Okay, so I need to find two numbers that multiply to 36 and add to negative 15, and then each one of those numbers will go into one of the sets of parentheses that I have. So there's no quick shortcut method for this. You got to just try stuff. So 9 times 4 I know is 36. And since they have to add to a negative number, I'm going to need both of these to be negative. But negative 9 and negative 4 make 13, not 15. Negative 9 plus negative 4 is negative 13, not negative 15. So that's not going to work. What else multiplies to 36? Well, I could do 12 times 3. And then sure enough, negative 12 plus negative 3 or negative 12 minus 3 is going to give me negative 15, which means those two numbers are what I'm looking for. So x minus 12 is going to be one factor, and x minus 3 is going to be the other. If you want to put x minus 3 first and then x minus 12, totally fine. That'll work. But this is kind of the setup that we're going to be doing right here, is two numbers that multiply to c and add to b. So if I look at the second problem, I want two numbers that multiply to 3. Again, we always want to check to make sure that the x squared doesn't have a number in front of it. Again, further videos will look into what happens if there is a number in front. But for now, as long as it's just plain x squared, I can go through this process that we've been working on. So I need numbers that multiply to 3, but add up to positive 4, because that's my b value. And this is nice because there's only two numbers that multiply to 3. It's 3 and 1. And sure enough, those add up to 4. So it's great. I have x plus 3 and x plus 1. And again, because this was x squared, the only way to get x squared through multiplication is to multiply a couple of x's together. So then this is our factored form. Okay. Again, you are producing two sets of parentheses that could be multiplied to get the trinomial. Okay. So same idea. But today we're going to see what happens if c is less than 0, meaning c is a negative number. Okay, so the process is still going to be the same. Okay, in this case, my c value is negative 12, and my b value is positive 4. Okay, so I need two numbers that multiply to negative 12, but add up to positive 4. Now, the reason that I saved this for the second video is because if two numbers are going to multiply to negative 12, I need one positive and one negative. Okay, two positive numbers won't work, and two negative numbers won't work, because if I did that, it would multiply to a positive, not a negative like we have here. So what I'm going to do is I'm going to just try some stuff. What do I know that multiplies to 12? That's where I would start if I were you. What are some things that multiply to 12? And the first thing that comes to my mind if I'm trying to multiply to 12 is 6 and 2. Okay. Now, right now, 2 plus 6 is 8. So it might seem like we're off, but because this is a negative 12, I need to assign one of these two numbers in red to be negative. I either need negative 2 and positive 6, or I need positive 6 and negative 2. And the way I make my decision is which combination of those numbers will add up to positive 4. So if I try to do negative 6 and I do 2 plus negative 6, I get 4, but the problem is it's negative 4. So that means all I have to do is take my negative sign and switch which number it's with. And sure enough, negative 2 plus 6 is going to give me positive 4. What that means now is I'm ready to put my binomials down, x minus 2 and x plus 6. Now, I've talked in the past, I've mentioned a couple times that the order doesn't matter, and it doesn't, okay? But the sign in front of the number does. If you want to put 6 in the first set of parentheses, that's totally fine. But if you do that, it would have to be x plus 6 and x minus 2. Okay? Either one of these is acceptable. What would not be right is if you said x minus 6 and x plus 2, because these are not the numbers I wanted, right? Those numbers there do not match those numbers there. So just be careful with this. I'm going to get this off the screen before it's too confusing. Okay? Either one of those would be a correct answer. So if we take a look here, x squared minus 7x minus 18. Again, I have no a value or no number in front of x squared. So I know it's going to be x times x. I need numbers that multiply to negative 18 but add to negative 7. First thing comes to mind for 18 is 2 and 9. Now the question is, since it's negative 18, if I make one of the blue numbers negative, will they add up to negative 7? Okay. And sure enough, mess around with this a little bit, but 2 plus negative 9 does give me negative 7. So those are the numbers I'm looking for. So x plus 2 and x minus 9 are my factors there. Okay. Same idea. If the c value is negative, we got to slow down because one of the numbers is going to be negative, and that can throw you off a little bit. So go ahead, pause now. Try these two problems. What I would suggest you do is, since there's no b value written here, you put a 1 in front. Okay, so go ahead and give these two a shot. Here, I know that if I've got a c value of negative 20, so I need two numbers that multiply to negative 20 but add up to 1. Okay, this can be a tricky number combination. A lot of students see that 1 and think they have to use the number 1. But as you see, there's no way that 20 minus 1 is going to equal to 1. That equals 19. Okay, so that's not the number set I want. What I'm actually looking for here is 5 and 4. 5 times 4 is positive 20. So then the question is, which one of these do I want to make negative so that they add up to positive 1? And if I do 5 plus negative 4 or 5 minus 4, that gets me the sum of 1 that I'm looking for. So x plus 5 times x minus 4 is my factored version of that trinomial. Okay. For the second U-try problem, I got negative 24, and this has to add up to negative 5. Okay. Now, if we want to go next level with this a little bit, the fact that the b value is negative, okay, the fact that this number right here is negative means that when I find two numbers that multiply to 24, the bigger of the two numbers that I write down, the bigger number is going to have to be the negative one. If that didn't make sense, you can wipe the last 10 seconds from your brain. Okay. So what multiplies to 24? 6 times 4 is 24, but there's no way to turn one of these negative and get 5. Right. So then 6 and 4, again, let's try 8 and 3. 8 minus 3 would be positive 5. So then I'm just going to take the negative sign and switch it over to the 8. Negative 8 plus 3 gives me negative 5. So then my factors, or my sets of parentheses, will read x minus 8 times x plus 3. Okay. Again, still has to multiply to c and add to b. Okay. Now, we're going to just briefly touch on this in this video, and then this will show up further and further on. What happens if there is a number in front of x squared, such as 2? Okay. If there's a number in front of x squared, the whole process we've been doing of what multiplies to c and adds to b goes out the window. Okay. That process only works if the number in front of x squared is 1, or if there's no number in front of x squared. Okay. But we did talk in the first half of chapter 8 about this thing called a GCF. Okay. And GCF stands for the greatest common factor, meaning it's something that you could divide out of every term that you're looking at. So if I look very specifically at 2x squared plus 12x plus 16, what do these three terms have in common? They don't have x in common because 16 doesn't have x with it, but they do, the coefficients or the numbers in front can all be divided by 2. Okay. If I recognize that, what I'm going to do is I'm going to take 2 out. I'm essentially going to factor out the GCF of 2, and I'm going to write down what's remaining. So if I divide everything by 2, the numbers are just being divided by 2. So instead of 12x, I have 6x, and instead of 16, I have 8. Okay. Now, the reason we want to do that is because what's remaining in the parentheses is something I can factor just like we've been doing. Okay. So I'm just going to kind of put my blinders on and just look at x squared plus 6x plus 8. And I want to find two numbers that multiply to 8 but add up to 6. Well, first thing that comes to mind for 8 is 4 and 2. 4 times 2 is 8. And sure enough, 4 plus 2 is 6. So that means the highlighted part can be written as x plus 4 and x plus 2. Okay, that's just the highlighted version. The question is, what do I do with that 2? What do I do with this 2 that we took out in the beginning? And all you have to do is just kind of bring it down and put it out front to the first set of parentheses. And that's it. Because if I were to distribute these together, I would get this. And then if I were to take the 2 and distribute that through, I would get the original problem. Okay. So the final answer we're looking for here is this. 2 parentheses x plus 4 parentheses x plus 2. Okay, so if there's a number in front of x squared, check to see, can I take it out of all three terms? Okay, and that process is called having a GCF. We're going to get this out of the way quick. All right, so here, 3x squared minus 15x minus 18. All of these numbers can be divided by 3, so I'm going to go ahead and take 3 out, or divide all of the coefficients by 3. Okay, and then again, I'm going to focus just on this trinomial now, this new one with smaller values, and see if I can find two numbers that multiply to negative 6, which is my new c value, but adds up to negative 5. Okay, now the fact that it has to multiply to negative 6, I will tell you right now, is a number combination that a lot of students struggle with because they think it's got to be 2 and 3. 2 times 3 is 6, 2 plus 3 is 5. The problem is, since it has to multiply to negative 6, I need to change one of these to a negative number. Okay. Well, now it no longer adds to 5. If I combine negative 2 and 3, I get 1. So then some students would be like, well, I'll just make them both negative. Well, what's the problem with these two numbers? The problem is it doesn't multiply to negative 6 anymore. It multiplies to positive 6. Okay. So this is a tough number combination, but it's actually not 2 and 3. It's going to be 6 and 1. So 6 times 1 is 6, and if I turn the 6 into a negative, negative 6 added by 1 gives me the negative 5 that I'm looking for. So that means I have factors, or parentheses, or binomials, of x minus 6 and x plus 1 with a GCF of 3 out front. Okay. So anytime you see a number in front of x squared, the first thing we're going to think is, can I take it out of all three terms? And a lot of times you can. So we're going to pause here real quick, try these last two, and we'll wrap up this video. All right, so 5 is usually pretty easy to check because if the number ends in a 0 or a 5, then it can be divided by 5. So this works here. X squared, 35 divided by 5 is 7, 50 divided by 5 is 10. Now I want two numbers that multiply to 10, which is my new c value, but adds to negative 7. Okay. Remember, if it's got to multiply to a positive, I either need two positives or two negatives. And since it's going to add the -7, I need a couple of negative numbers. Through some trial and error, I find that -5 and -2 work out. So I get x minus 5 times x minus 2 with the GCF of 5 out front. Okay. And then finally, for this last one, you may not know whether or not 7 goes into 105, and I don't expect you to know that. But we can check in the calculator, 105 divided by 7. And this actually helps us because then it makes the next step even easier. 7 does go into 14, so it means I can write this as x squared plus 2x minus 15. And I know it's 15 from the calculator right there. So now I need factors of -15 that add up to +2. So if you think about what multiplies to 15, first thought is 5 and 3. Since it's -15, one of them's got to be negative, and 5 minus 3 will give me the +2 that we're looking for. So x plus 5 times x minus 3 with the 7 out front. And we are done. Nice work. Good job. You did it. This is going to act as our summary today. If you see, we're just going to kind of look at the 4 different situations. If you see both positive numbers, then you're going to factor, or your factored answer should look like x plus and x plus. Okay, 2 positive numbers in those parentheses. If C is positive, but your B value is negative, then I need 2 negative numbers. So x minus and x minus. Okay. If the C value is negative, but B is positive, I need 1 positive and 1 negative. Okay. And again, kind of next level, the larger number will be positive because it has to match the sign of B. And then finally for this last one, this is also going to be x plus times x minus. And here the larger number will be negative. Larger number will be negative. Hopefully it's starting to make sense. We'll add on to this in a little bit, but we're done here.